Hello everyone, my name is Han Xiaotan and I come from Llama Institute. Today it is my honor to present our work, Explainability-Aware One-Point Attack for Point Cloud Neural Networks. This work focuses on the topic of adversarial attacks on point clouds. There are already several studies investigating this topic. Some of them have mentioned the role of critical points. However, there is a gap in how these critical points are distributed and how sensitive the predictions are with respect to the points. There are mainly two popular ways to check critical points, which is widely applied in the existing studies. The one is to find the active points after the pooling layer, and the other is to backtrack the points which have large gradients. However, both methods have the drawbacks that they cannot accurately locate the critical points. We introduce explainability methods that compute attributions for each feature of the input. Here we employ integrated gradients, which works by setting a baseline, then sampling from the path between the baseline and the current input, and finally calculating and integrating their gradients. The attack method is intuitive. We are only interested in those critical points, and therefore only perturb the points with the largest attribution in the explanations generated by IG, while the other gradients are masked. CTA is a multi-point attack method that traverses top k critical points in reverse order, starting with the most important one and until the prediction label changes. The result shows that the proposed method can attack the network with almost 100 success rate, although the perturbation distance is large, but only one point is required to be shifted. In addition, CTA could theoretically attack all instances, since it would traverse all points in the end, but only 6 points are needed on average to fool the model for all inputs. From the initial model PointNet to the current best performing network PointMLP, almost all point cloud models are sensitive to perturbations at critical points. We think this is because some kinds of pooling layers in the model concentrate the attributions on very individual points. Experiments show that structures such as median pooling, for example, which are unaffected by extreme values, can successfully resist the effect of the perturbations on critical points, but the performance is also degraded at the same time. Another conjecture is that the absence of multi-size convolutional kernels like in image networks weaken the point-wise correlations. We perform the same attack on images, but the result shows that their stability is much stronger than point cloud models. On the other hand, the attack can be regarded as a measurement to evaluate the explanations. Intuitively, if the explanation is more plausible, the more accurate the critical points are located, and therefore the higher success rate the proposed attack should achieve. Here is the references, and I will appreciate for your attention.